Alright, let's talk linear models. In this situation here, we have two landscaping companies. What they do, they both have a service call fee, so that's a flat fee they charge, and they have some kind of hourly rate. Alright. Then what we're given is some information. Let's look at Walton's landscaping service, for instance, right here. In this case, a 5-hour service costs $185 and a 2-hour service costs $107. To make things easier to work with here, I'm going to write these in a table. So I'm going to put hours here on the left side, and we'll do cost over here. So for a 2-hour service, it costs $107, and this is in dollars here. And then for a 5-hour service, it costs $185. Now, importantly, it's important to look at and see. So for a 2-hour service, it costs $107, but we can't just take the $107 here and divide it by the 2 to find out how much it is per hour, because this $107 right here, this also includes some kind of service call fee. We don't know if they charge $80 just to show up, or $20 to show up, and that's going to influence how much the hourly rate is. But what we can do is compare these two situations. The comparison is, what's the difference in the 3 hours that were added between these two services? So both these service charges of $107 and $185 each have this service call fee. The only difference between their overall costs is these 3 extra hours. So this is the important bit right here, is that when you add 3 hours, you add $78. And now with that information, we can find out the cost per hour. So it's $78 for 3 hours of service, which gives us $26 per hour. And again, we can, in this case, this is a direct comparison between adding hours and the cost that it's adding. And so this gives us our dollar per hour charge. Now that we know our dollars per hour, let's revisit this first situation here. So at 2 hours cost us $107. So the difference between how much the hours cost us, so 2 hours at $26 per hour, is $52. So that's the charge for the 2 hours of work. The difference between that value and this 107 must be the charge that they charge out the gates, or the service call fee of $55. Alright, now that we have both our pieces of information, and again, this is $26 per hour, and the service call fee is $55. Our linear model, as they describe to us, they want X to represent the number of hours of service, and C is the cost of service. In the linear model, then would be the cost of service is $26 times X, which is the number of hours they've worked, plus this $55 service call fee. We can attack this problem in a slightly different way, getting the same answer. We'd be treating these two pieces of information as points. And first finding the slope and then the y-intercept. The slope is this dollar per hour, $26, and the y-intercept is at $55. So to do this differently, let's instead of setting up the table as I did above, let's think of these as 2 points. These could be points 2, 107 and 5, 185. And what we can do is first find the slope between these 2 points, which is the y2 minus y1 over x2 minus x1. So in this case, the slope m would be 185 minus 107 over 5 minus 2. This gives us 78 over 3, which is 26. That's our slope, and again, that's identical to the same work that we did above here, finding 78 and 3. Then what we can do is plug this into our general form, and again, our general form in this case is going to be C equals mx plus b. our M value is what we just found, so now we have C equals 26x plus B. And then what we can do is plug either one of these points in for our two variables, x and c, x being the number of hours, c being the cost. Let's plug in this first point here. Getting our c value is 107, that's the cost. 26 times the number of hours, which is 2, plus b, get 107 equals 52 plus b. Subtracting 52 from both sides, and we get 55 equals b. So this b value we plug back in for b up here, and what we end up with is exactly the same answer that we had before. Our b value here, or the cost of this showing up the service, is $55, and the cost per hour is $26.